Okay, today we are going to be learning some more factoring patterns. So there's going to be some new factoring patterns that we're going to learn on our, you know how we have that factoring checkoff list in my classroom on the wall? Well, we are going to learn a few more of those. By the end of this chapter, we will have completed that whole checkoff list. So just as a quick refresher, find the sum, difference, or product. So you're going to have to look and see what's happening with your problem. So on question number one, and this looks like an addition sign. So we're just going to combine like terms. Z squared plus 5z squared, that's 6z squared. And then 5z plus a negative 11z is a negative 6z. And a negative 7 and a negative 6 is negative 13. Okay, number two looks like it is a multiplication problem. So we're just going to do that distributive property. So 2a times a squared is 2a to the third. 2a times a negative 10a is a negative 20a squared. And 2a times a negative 2 is negative 4a. And negative 3 times a squared is negative 3a squared. Negative 3 times negative 10 is plus 30a. And negative 3 times negative 2 is positive 6. Combine all our like terms, and we have 2a to the third minus 23a squared plus 26a plus 6. Okay, so here we go. This one says factor the polynomial completely. So we got to look for the greatest common factor first. Remember, that's always our first step. So if I look at this problem, number 3, I've got x to the third minus 7x squared plus 10x. Looks like to me I have a GCF of an x. They all have the variable x common to them. So I'm going to factor out the x. That leaves me with x squared minus 7x plus 10. And then we're going to do factor pairs of x, that x squared, that's just x and x. And factor pairs of 10 are 1 and 10 and 2 and 5. So remember, this sign right here is positive, so that means the two signs have to be identical inside the parentheses, and they have to be negative since we're looking for a negative 7. We want the factor pairs of 10 that add to give us negative 7. Well, that's going to be 2 and 5. And subtract and subtract. Make sure as you keep factoring, guys, that you always bring down the GCFs. Make sure that every piece is in the final answer. Because remember, whatever you get as your factored form, if you were to take and multiply it out, it should give you the original. So you got to have all the pieces so that when you multiply it out, you'd end up with the original problem. Okay, over here we've got 3x to the 6th plus 12x to the 4th minus 96x squared. So looks like to me those are all divisible by 3, and they all have an x squared common to them. So I'm going to factor out a 3x squared. That's going to leave me with x to the 4th plus 4x squared minus 32. Okay, so now this one's a little different because this isn't an x squared, it's an x to the 4th. But factor pairs of x to the 4th are x squared and x squared. And factor pairs of 32, we got 1 and 32, 2 and 16, 4 and 8. I think that's it. So what we are looking for now is this ends in a negative, so we want the factor pairs that subtract to give us a plus 4. So I think I'm going to use 4 and 8. So 3x squared comes out in front. I'm going to put my x squared, 4 and 8, and then we want that to be a plus 8 and a negative 4. That'll give me a positive 4x squared. Okay, this will keep factoring. X squared minus 4 is the difference of perfect squares, so that's going to factor to x plus 2 and x minus 2. And x squared plus 8 is the difference, is the sum of squares. So that's the one that factors with the I. So x plus 2 root 2I. I ran out of room. And x minus 2 root 2I. Remember, the factor pair for 8, you have to use square root of 8 times square root of 8. And square root of 8 is 2 root 2. So that's where I got the 2 root 2 from. Okay, number 5. Looks like to me I've got a GCF of a 2y to the third. So I'm going to factor that out. That leaves me with y squared minus 9. Okay, so once again, you have to look inside the parentheses. A y squared is you got to think, okay, that could probably factor again. You want all of those factors to be in the parentheses to be usually like an x to 1 power or y to 1 power. If you can get them down to a single power, that's what you want to have happen. So got to look closer at the y squareds. That's a difference of perfect squares, so that one's going to factor again. Y plus 3 and y minus 3. Okay, number 6, the first thing I notice is they're all divisible by 4 and they all have z's in them. So my GCF is going to be 4z squared. That's going to leave me with z squared minus 4z plus 4. Okay, so now I'm going to go ahead and factor that. Factor pairs of 4, I'm going to use 2 and 2 because we want them to add together to give us a negative 4. So z minus 2 and z minus 2. It's the same set of parentheses, so I'm going to go ahead and write that as a binomial squared, like that. Okay, so now we're going to learn the sum and difference of perfect cube patterns. So in order to recognize those, if you look right here, this is sum of cubes. Notice how there's not a middle term, it's just two terms, something to the third power plus something else to the third power. And then same thing with the difference of cubes. It's something to the third power minus something to the third power. So quick refresher, what are perfect cube numbers? Well, if you want to figure out what they are, you just start taking your counting numbers. Well, you can start with 0, but it's not going to do anything. Take your counting numbers and raise them to the third power. 0 to the third power is still 0. 1 to the third power is 1. 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. Whoops, I didn't want to write 3 again, sorry. Meant that to be a 6. 6 to the third, 216. 7 to the third is 343. 8 to the third, so you could just keep this pattern up. 8 to the third, we mostly is 512. We might as well go to 10. 9 to the third, so if I'm going to do 9, 9 to the third is 729. And 10 to the third, so if I'm doing 10, 10 to the third is 1,000. So these are perfect cube numbers. These are numbers you're going to want to look for in your factoring. Now, this one is a little tricky, number 64, because sometimes you might think that's a perfect square because it goes in both patterns, and 1 also can go in both patterns because those are both perfect square numbers and perfect cube numbers. So when you're looking for your sum and difference of cubes, you got to make sure, does the 1 or the 64, is it being used as a perfect cube or is it being used as a perfect square? That will make a difference on how you factor. Okay, so let's look at some problems and see how this works. So w to the third minus 27. W to the third, that is a perfect cube. 27 is a perfect cube. That was on our list. It's 3 to the third power. So basically what we're looking at is difference of two perfect cubes. W to the third minus 3 to the third. Okay, so how we're going to factor this, we're going to do this with guess and check, just like we've always done. W to the third, though, doesn't break apart evenly. It's got to go W times W squared. Okay, and then 27, we have factor pairs of 27. So let me put this here. So my factor pairs of 27 are 1 and 27 and 3 and 9. Okay, you want to use the one, oh, I should have left it written as 3 to the third. You want to use the factor power, or the factor pair that has the factor that's the perfect cube. So 3 to the third is 27, so you want to use the factor pair with the 3. Okay, when you go to do your parentheses, this one's a little different in that instead of having two of the same size parentheses, you're going to have a smaller one and a bigger one. So when I do this, I go ahead and out of my w times my w squared, I always put the smaller numbers in the smaller parentheses. So w is less than w squared. So w goes here, w squared goes in the first spot on the second parenthesis. So same thing with the 3 and the 9. The 3 is the smaller one. It's going to go in the smaller parenthesis or on the left. And then the 9 is the bigger one, so it goes on the end. Okay, now because this original sign was a negative right here, this sign right here is going to be negative always. And then this sign on the end is always going to be positive. Okay, now this is where you have to take a minute to figure out why am I not done? I feel like guess and check, we've done the first and the last terms, we should be done. Watch what happens when you multiply this out. You get w to the third plus 9w minus 3w squared minus 27. So that 9w and that minus 3w squared didn't cross out. They don't because they're not conjugates. But we want them to cross out because we don't want any middle terms. So this is the only one where you're going to have to create a middle term. So to create that middle term, try to think to yourself, okay, negative 3w squared. Come back to this first w. So I'm going to think of my negative 3. So I'm going to think of this one right here. And then start right here with this w. W times what? So what could I put in here? So I've got this negative 3w squared. What could I multiply w times so that it would add to 0? Well, what if I did 3w? W times 3w. So if I put a 3w here, that would make 3w squared. Okay, let's check that and see if that's going to get everything to drop out. So once again, I'm going to go w times w squared, that's w to the third. W times the 3w, that was the 3w squared, which we just created. W times 9 is 9w. Negative 3 times w is negative 3w squared. Negative 3 times positive 3 is negative 9w. And negative 3 times negative 9 is negative 27. And look, they ended up crossing out, and we ended up with w to the third minus 27. So in our sum and difference patterns of cubes, guys, you're going to have to create this middle term right here. You won't be able to see it from your factor pairs when you first put them in the parentheses. It's not too hard to figure out that number, but you're going to have to remember to put it in. Okay, let's come over here and try that again on number 8. So when I look at number 8, 125 is a perfect cube number and 216 is a perfect cube number. They're over here on our list. 125 was 5 to the third and 216 was 6 to the third. So when I do my factor pairs, then I know for 125 I'm looking for the perfect cube numbers, right? So when I do my factor pairs, I'm going to do 5 times 25 because 5 to the third. N to the third is going to be n times n squared. 6 to the third, that's going to be 6 times 36 as my factor pair for 216. So basically, guys, if you've got 5 to the third, one of the 5s comes out here in front, right here, and then the other two 5s multiply together to give you the other factor pair. It's pretty easy to figure out what factor pair you should use once you recognize the perfect cube. So 6 to the third, I put the 1 6 here, so 6 to the third. That 6 goes right here. These two multiply together to give you the other factor pair. Okay, now let's put them in our parentheses. So because it's a sum of cubes, remember this is the one where we're going to have a smaller parenthesis and a little bit bigger parenthesis. So smaller numbers always go in the small parentheses. So the 5 goes here and the n, and then the 25 and the n squared goes in the front. Okay, and then the 6 is the smaller number, so it goes right here. And then 36 goes on the back end. This sign is a plus, so that first sign is a plus. The sign on the end is always positive. So remember, we're trying to figure out what number we have to put in this middle spot right here to create it so that everything will add to 0. To do that, just check these two numbers right here. 6 times 25 is 150. Take this first number, 5 times what will give me 150 n squared. That's 30. So oops, I don't want that to be a plus, sorry. Because we want it to add to 0. It's a plus 150, so we want it to be minus 30n. That's the number that goes in there. Okay, that's factored. So 5n plus 6 times 25n squared minus 30n plus 36. So guess and check pattern, guys, works. The only thing you have to work at now is trying to figure out this middle number right here. Okay, so you can still do the first and the last factor pairs to figure out what you're looking for. Let's try another one. So let's try number 9. Okay, so first of all, you have to recognize what pattern we've got going on. Well, 8 is a perfect cube number. That's 2 to the third. 343, perfect cube number. That's 7 to the third. So when I choose my factor powers of 8, or factor pairs of 8, I want to do 2 times 4. 343, I'm going to do 7 times 49. I probably wouldn't think of 7 times 49, 343, but since I know it's a perfect cube, I know one of them has to be a 7, and then I know the other two multiplied to give me the other pair. And then the c is c times c squared. Okay, here we go. Parenthesis, parenthesis. All right, little numbers in front, bigger numbers in the second parenthesis. So little number in the first parenthesis, bigger number in the last parenthesis. This sign is a plus, so that sign has to be a plus. All I got to do is figure out, this is a plus 28 right here. This is a plus 28c squared. So 2 times what will give me a negative 28? That's what I'm looking for. I want a negative 28c squared, so I'm thinking that's got to be negative 14c. And the n sign's always positive. Okay, should we check and see if it's right? So 2c squared times that's 8c to the third. 2c times negative 14c is negative 28c squared. 2c times 49 is 98c. Okay, 7 times 4c squared is positive 28c squared. 7 times negative 14 is negative 98c. And 7 times 49 is plus 343. And you can see everything here cancels out, and we end up with 8c to the third plus 343. So it matches. Okay. One last one over here. I'll just erase all that step right there. So over here, we've got 16x to the fifth minus 250x squared. Do I have a GCF? I think they've got an x squared, and I think they're both even, so I'm going to go with 2x squared. So I'm going to take my 2x squared out. I'm going to have 8x to the third minus 125. Okay, those are perfect cube numbers. This is 2 and 4, because 2 to the third is 8, so I want to use 2 and 4. And 5 to the third is 125, so I want to use 5 and 25. So when I put this in, 2x, 4x squared, 5, 25, negative sign in the middle, so that first sign is negative. It always ends in a positive, so the only thing I'm trying to find is this number right here, right? Okay, well, we can do that with the guess and check. So we check these two numbers right here. Negative 4 times 5 is negative 20. 2 times what gives you negative 20? You want it to be opposite because we want it to add to 0. So we're going to do 2 times what gives me positive. So we're going to go 10x. So if you are having a hard time with, oh, I can't get the middle term, what are you doing multiplying? Okay, let me show you. That's the answer right there, guys. Let me show you how this works with if you just wanted to think of it as the pattern, because some of you guys might be like, well, I just want to do the pattern. I don't want to do guess and check. I just want to do the pattern. Oh, let's add one problem right here like this. So if I just want to do the formula, so I'm going to make up a problem here that's going to be perfect cube. So I'm going to do 27 x to the third plus 64. Okay, so this is a sum of cubes because it's 3 to the third x to the third plus 4 to the third. Okay, they're all perfect cubes. My formula says this, a to the third. I'll show you how it matches the formula. I usually just do guess and check, but I'll show you how it matches the formula. We have two parentheses here. Okay, so this right here, a to the third plus b to the third. So a to the third is going to represent this piece right here, and b to the third is going to represent that piece right there. So when you look at it and you try to figure out a to the third, well, that means a is 3x. Because if I take 3x and raise it to the third power, that gives me 27x to the third. Okay? So then what does b have to be? Well, b is 4, because 4 to the third is 64. All right, once you know what a and b are, then you just plug them in your formula over here. A is 3x, b is 4. Then I take a and I square it. Well, a squared is 3x squared is going to be 9x squared. Then it says take opposite of a and multiply it by b. What's that give you? Negative 12x. And then what does it say to do on the end? Take b and square it. 4 squared is 16. So that's following the formula. Does that follow our guess and check pattern? Yeah. 27x to the third plus 64. I would do 3 times 9. X times x squared. I would do 4 times 16. So see how these numbers right here, this 16 ended up right there in the formula. This 4 ended up right here. This 3 right here, this x right here, 9 here. The only thing we didn't get from our factor pairs was the middle term. And if you want to just think about the formula for the middle term, it's the opposite of these two multiplied together. 3 times 4 is 12. Opposite of that is negative 12. That's what goes in the middle. So you can do the whole guess and check and try to figure it out. You can take the first one and multiply them together. Whatever, you just got to know how that pattern works. Guess and check, memorize the formula, I don't care. You just got to know how to do sum of square or sum of cubes and difference of cubes. Okay, and then the last one is factoring by grouping. So if you notice on this one actually has 4 terms in it. Up to this point, our polynomials had either 2 terms or 3 terms. This one now has 4 terms, so that's going to be your dead giveaway that it's got to be grouping. And you're going to group them in sets of 2. So for grouping, I'm going to group the first 2 together and the last 2 together. It doesn't really matter which 2 you group together, but it's just as easy to do them how they're written. So just do the first 2 and the last 2. So then look at the first 2 and decide what's your greatest common factor out of the first 2? It's x squared. So that's going to be x minus 3. Okay, what's my greatest common factor out of the last 2? Well, it looks like it's a 16. But I always like my leading term to be positive, so I'm going to factor out a negative 16. And that's going to give me x minus 3. Okay, notice how this piece right here is the same as that piece right there, my little hearts. If they are not the same, then this will not factor by grouping. If they are the same, you can continue factoring. So how do I continue factoring? Well, let's just backtrack for a minute and let's just say instead of this parenthesis x minus 3, let's just say you had a problem that said x squared and then m minus 16 and then m. So instead of this x minus 3 right here, I'm putting an m. What do you notice now is common to both of them? It looks like it's the letter m. So take the m and put it out in front, and what are you left with? X squared minus 16. That's what we're going to do up here. We're going to use these hearts or whatever you want, the x minus 3. It's the same parenthesis. It comes out in front as a greatest common factor, and then you're left with x squared minus 16. Okay, so x squared minus 16 keeps factoring though. So x minus 3, x plus 4, x minus 4. Remember, this is a degree 3, so if I multiply all this out, I should end up with a degree 3. And I would get a degree 3 if I did x minus 3 times x plus 4 times x minus 4. That would give me a degree 3. Okay, let's try it again. Over here, I'll group the first two and the last two. So I notice out of the first two, I could take out an x squared. That leaves me with x plus 7. Out of the last two, I'm going to take out a negative 9. And that's going to leave me with x plus 7. So next thing you want to do is make sure that this parenthesis is identical to that parenthesis. And it is. So that's now your common factor. That's your GCF. So that comes out in front. And what are you left with? X squared minus 9. And x squared minus 9 is difference of two squares. So we're going to go one more time. X plus 7, x minus 3, and x plus 3. Okay, so now we're going to solve, and we could do any of our factoring techniques that we've learned, just whatever's based on our scenario here, we're going to figure out what our answer is. So first of all, if I'm going to solve this, I'm probably going to put it equal to 0 and go from there. So 18s to the third minus 50s, I'm going to make that equal to 0. So 18s to the third then I'm going to look for a GCF. So it looks like to me my GCF is probably 2s. So 2s out in front, and then 9s squared minus 25 equals 0. Now keep in mind the highest degree is a 3, so when I'm done I should have 3 solutions. Well, inside the parentheses we have 9s squared minus 25. That's a difference of perfect squares. So that factors to 3s plus 5 and 3s minus 5. Okay, it's equal to 0, so now I can take every variable and solve that. So from this s right here, it's going to be 0. This s is going to be a negative 5/3, and this s is going to be a positive 5/3. There's our 3 answers. Okay, so 14, I'm looking at 14. I notice it's an m to the third, so I should have 3 answers when I'm done. I also notice that I have 1, 2, 3, 4 terms. 4 terms is a dead giveaway for grouping. That's how you want to start that one. And it's already equal to 0, so that's nice. I don't have to move anything around, so I'm going to group the first two, and I'm going to group the last two. So first two GCF is an m squared. That's going to be m plus 6. Next two, I'm going to factor out a negative 4. That's going to be m plus 6. I'm going to take a minute and look just to make sure that parenthesis is the same as that one, and it is. So that's now my new greatest common factor, so that's going to come out in front. And then I'm going to end up with m squared minus 4. This is all equal to 0. Don't forget your equal sign. And then m squared minus 4 factors, that's the difference of squares. M plus 2 and m minus 2. So m equals negative 6, negative 2, and positive 2. There's your 3 answers. Okay, down here, number 15. A to the fourth. Okay, so a to the fourth, I'm going to factor pair that one to an a squared and an a squared. We're already equal to 0, so that's good. So a squared, a squared. Factor pairs of 6, 1 and 6, 2 and 3. I want it to add to be a 7, so I'm going to go with 1 and 6. Okay, so here, this one right here is sum of squares. So you can either keep factoring, this one you can solve it two different ways. So I'm going to do it both ways so you can see what happens. So I'm going to take this parenthesis right here, a squared plus 1, and I'm going to factor it. That's going to go to a plus I and a minus I. And then the other parenthesis is going to go to a plus the square root of 6I and a minus the square root of 6I. Those are both sum of squares. So I need four answers. So x equals positive and negative I from the first two parentheses and positive and negative square root of 6I from the last two set of parentheses. Okay, so you could keep factoring it all the way out to its linear factors and just pull your answer from, oh, I guess it's not x, it's a. Pull your answer from there to figure out what a is. Or, since we're solving and it didn't say that I had to solve by factoring, I didn't have to show my factoring. At this step right here, okay, I'm going to go a different route. So at this step, I am going to come down here, give myself some room. I'm not going to factor anymore. I'm just going to say a squared plus 1 has to equal 0. Or the other parenthesis, a squared plus 6 has to equal 0. Okay, so I'm going to solve that for the letter A. So I'm going to subtract 1. And now I'm going to take the square root of both sides. And a is going to turn out to be plus or minus, and the square root of negative 1 is I. Look, same two answers. So same thing over here. I'm going to take my a squared. I'm going to subtract my 6. And then I'm going to take the square root of both sides. But remember, square root of a negative number is I, so a equals plus or minus I root 6. You get the same two answers. So you can keep factoring them if you want to using the sum of squares idea, or you could just go directly from the a squared plus 1 equals and solve that. All right? Okay, 16. What do we got here? 15x to the 5th minus 72x to the 3rd minus 108x. Okay, so for sure they all have an x. Wow, 108. I think they might all be divisible by 3. Let's check. 72, I think, is divisible by 3. And 108. Yep, they're all divisible by 3. So I think our GCF is going to be 3x. So remember, we need to have 5 answers when we're done because it's x to the 5th. So GCF is 3x. That's going to leave me with 5x to the 4th minus 24x squared minus 36. Okay, so factor pairs of 5 are just 1 and 5, so that's nice. I don't have to worry about that one. 36, though, I've got a few more choices. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Okay, there's quite a few there. All right, let's see which pairs we want. We want to subtract to be a 24. Let's put that equal to 0. So we know we have to do 5 and 1. So we want to subtract to give us a 24. So how about 6 and 6? 6 times 5 is 30, minus 6 would be 24. Let's try 6 and 6. So we want it to be a negative 24. And, whoops, x squared and x squared, sorry. Okay, because it was an x to the 4th. All right, so now this one right here, x squared minus 6, I could factor that one to difference of squares, x plus root 6, x minus root 6. I could do that one. That one's not too hard. I don't know that I really want to do 5x squared plus 6 and do that as sum of squares and do square roots on both ends. So since we're solving, I think what I'm going to do is I'm just going to go ahead and start solving right now. So from this x right here, I know x is 0. That's one of my answers. From this parenthesis right here, I'm going to say 5x squared plus 6 equals 0. Subtract my 6. Um, divide by my 5. And then I'm going to take the square root of both sides. This one's kind of a not nice answer. So we end up with plus or minus I, the square root of 6, over the square root of 5. And if you rationalize that, you end up with square root of 30 over 5. I square root of 30 over 5. Okay, so there's two more answers right there. And then my other two answers are from my parenthesis here. So x equals plus or minus the square root of 6. There's all 5 answers. So you can set up a mini equation and solve it if you just have an x squared by itself, or you can try to factor it into its linear pairs. Solving is nice because you can short step the factoring if it's not a nice difference of squares or sum of squares. Okay, here we go. Two more, so already equal to 0, so that's nice. Looks like to me GCF is a 4x. And whole thing is already equal to 0, so nice. So now we're just going to factor. So factor pairs of 9, I'm going to go with 1 and 9. Subtract. It's going to give me a negative 10 in the middle. So these are easy for me to factor, so I think I'm just going to keep factoring. X plus 1, these are both difference of squares. So x plus 3 and x minus 3. So my answers are going to be, I need to have 5 of them, so x equals 0 is the first one, positive and negative 1 is the second, and positive and negative 3 are, sorry, positive and negative 1 are 2 and 3, and positive and negative 3 are 3 and 4. So there's our, or 4 and 5, sorry. There's 5 of them there. Take my word for it. All 5. Okay, now 18 is not equal to 0, so I'm going to rearrange it. 2x to the 5th minus 14x to the 3rd plus 24x equals 0. You want to make sure it's in descending order in standard form. GCF on this I think will be a 2x, so factor out a 2x. And that's x to the 4th minus 7x squared plus 12x. And then factor, so it's an x to the 4th. So x squared and x squared. 12, I think I'll use the factor pairs of 3 and 4. And they're both subtractions. So these ones are not bad for me to factor as difference of squares, so I think I'll just keep factoring x plus the square root of 3, x minus the square root of 3, x plus 2, x minus 2, whole thing's equal to 0. So I should have 5 answers, and I do. X equals 0, positive and negative square root of 3, and positive and negative 2. There's all 5 answers. All right. These two are the tough ones right here. These are our difference of cubes and a sum of cubes pattern. Look, I recognize there's no middle terms here. It's just one term, two terms. So that's got to be one of our special patterns. It's either got to be sum of squares, difference of squares, sum of cubes, or difference of cubes. And it's difference of cubes. It's x to the 3rd. So 64, what cube is that? That's 4 to the 3rd. Okay, I'm ready to go. We've probably already forgotten how to factor it. That was the first of our lesson. So I'm going to go x and x squared. 64, I'm going to do 4 and 16. All right, so x squared, 4, 16. This sign always matches. This sign right here always matches that one. And then it's plus 4x in the middle and a plus on the end. Okay, this part right here, x minus 4, easy to get an answer. X equals 4. This parenthesis right here will never factor. It will always have to go in the quadratic formula. And it's probably going to be imaginary when you're done. So let's put in the quadratic formula. And let's see what the discriminant is. So x equals -4 plus or minus the square root of, you're going to have 16 minus 4 times 16, -48 is going to be imaginary. So that's going to turn out to be, oops, I'll go with 16 times 3, so -4i root 3 over 2. Remember, the 2 has to divide into both pieces. So you have to do the dividing the 2 last. You have to wait till you reduce your radical before you can divide by the 2. So x equals -2 plus or minus 2i root 3. Okay, there's your other two answers. So x equals 4 is one answer, and then the -2 plus or minus 2i root 3 are the other two answers. Okay, one more time. Let's try it again. So once again, I recognize this is sum of cubes. I got to get it factored first. Well, 2 to the third is 8, and 3 to the third is 27, so I know I'm working with a 2 and a 3. So 2x, 4x, 3, 9, that's a plus, so that's a plus. Minus 6x, got to get the opposite in the middle, so everything drops out, and then plus 9. Okay, from first parenthesis, x equals a -3/2. Second parenthesis will never factor. Always has to go in the quadratic formula. And this one will give you an imaginary number. Okay, so x equals 6 plus or minus square root. Let's figure out what the discriminant is. So 36 minus 4 times 9 is -108 over 8. Okay, 108. Let's see what we can work with 108. 108. It is divisible by 4. Let's see if it's divisible by 9. Yeah, it is. Oh, it's divisible by 36. 108 divided by, yeah, let's do 36. So x equals 6 plus or minus, so this is, I'm going to do 36 times 3. So -6i or square root of 3 over 8. Okay, so this doesn't, 8 doesn't divide into 6 evenly, but you can reduce the fraction. So 6 over 8 is 3/4. And then this one right here is still 3/4. So 3i root 3 over 4. So you could write it as it's two separate pieces like that if you want. You could leave it over one fraction also. Since they're both 4, you could leave it like that, and that'd be okay also. Okay, there's our other two answers. So we've got 3 answers. So when you have your sum and difference of cubes, guys, one of the answers is going to be real, and then the other two are going to be imaginary. You're going to have to use the quadratic formula to find all 3. All right, so now we have added to our factoring techniques. So in our special patterns, we have sum of squares and difference of squares. So we have the sum of squares, which is the one that factors with the I. Okay, and now we have, and difference of squares was the first one we learned. That just goes to A, they're just conjugates. Sum of squares and difference of squares are both conjugates. Difference of squares doesn't have the I, sum of squares does. Okay, now we have sum of cubes. So those are going to factor to what I call a little parenthesis and a bigger parenthesis. The bigger parenthesis has 3 terms in it, so if that helps you remember, it's a cube. Cube is 3. The bigger parenthesis has to have 3. So be it. Come up with little helpful hints to help you remember how to do these. So now we have sum of cubes and difference of cubes. Okay, and then we learned grouping. And in the grouping, we had 4 terms. And you grouped the first 2 and the last 2, and then you did a GCF. So basically, grouping is a GCF at least 2 times. Maybe 3 if the original problem had a GCF, but for sure 2. Okay, those are our new, these are the new ones right here. So top 2 we already knew, but it's good to refresh them. These are the 3 new ones right here. Sum of cubes, difference of cubes, and grouping. We only have one left, and that's factoring by synthetic division, and that's coming up in another lesson. Okay, we're done.